Hello, geometry students. We are getting into Unit 5, which is going to deal a whole lot more with triangles, which should sound like a familiar discussion we've been having here in the last few weeks. But specifically, we're going to be looking into right triangles and some of the special rules that apply with them. We're going to begin with one of the old familiars you should have learned back in junior high. The stuff we're going to go over today will sound largely very familiar, but we're going to use it in some different ways here in the next few days. But anyway, let's get started. Our objective is the student will learn to use the Pythagorean Theorem in order to solve for missing sides of right triangles. I anticipate that these will be the notes for Tuesday's class, the Tuesday following the Thanksgiving break. I am not sure what date that is, but you can always fill it in later on. So copy your objective, leave a space for your date if you don't know what the date is, and as always, press pause anytime you need more time, and then hit play whenever you're ready to move on. Okay, so let's get started. Okay, now some basic vocabulary that you are probably already familiar with, but go ahead and copy it down anyway. In our right triangle, our three sides have various names. The two sides that build the right angle of the triangle are called the legs of the triangle, and the side that is across from the right angle is called the hypotenuse. Hypotenuse is a Greek word that means longest side. And as we well know from our studies, we know that the largest side of the triangle is always going to occur from the largest angle of the triangle. Since the right angle is the largest angle, that makes the side that is marked in the picture across from the right angle, that makes it the hypotenuse. Okay, now as you are most likely familiar with, the Pythagorean theorem states in our conditional format, if a figure is a right triangle, that is our hypothesis, our observation. Okay, if we have a right triangle, our conclusion is then a squared plus b squared equals c squared. And as we have already established, a and b are the legs of the triangle, being the two sides that build the right angle, c being the hypotenuse. Of course, keep in mind, as the theorem states, you get a leg squared plus a leg squared equals the hypotenuse squared. Squaring a number does not mean to multiply it by 2. It means to multiply that value times itself. As silly as that sounds, that's one of the most common mistakes people make when messing with the Pythagorean theorem. Okay, so let's take a look at the theorem in action here. Here's an example. We know two sides of our right triangle. Okay, we have a 3, we have a 4, and we have an x. And of course, the instructions are to solve for the missing side length x. Okay. Obviously, we're dealing with the Pythagorean theorem, so what I would very much like to see on your papers is I would like to see the theorem written down without anything substituted into it. Simply write down a squared plus b squared equals c squared. I would like to see this not only in your notes, but also on all of your worksheets. We have a habit of trying to skip over these steps that we see as, oh, I don't need to write that down, that's silly, that's useless, but then we make all kinds of silly mistakes. So we're going to write down the theorem before we plug anything into it. Okay, now the key with Pythagorean theorem is you need to make sure that you plug your information into the correct location. Okay, don't just pick 3 values and plug them into any of the 3 locations. You've got to get the legs plugged in for A and B and the hypotenuse plugged in for C. If you do not put things in the right positions, you are guaranteed to get an incorrect answer. Okay, so let's see if we can figure out what are our legs for this particular problem. Well, clearly we can spot the right triangle, or the right angle in the upper right corner, and the sides that build that are the 3 and the 4, so they are the legs, and x is the hypotenuse. So plugging in, we have 3 squared plus 4 squared equals x squared. Okay, let's simplify some of the mess a little bit. We have 3 squared, which is 3 times 3. that is 9, and 4 squared, 4 times 4, that is 16. We do not know what x is, so there's nothing that we can do with x squared yet. Okay, so we can add the 9 and the 16. 9 plus 16 is 25, and that equals x squared. Okay, well, the very last step of our solving equations is to get a positive 1 coefficient for our variable and a positive 1 exponent for our variable. Okay, so our x does have a 1 for its coefficient, but it does not have a 1 for its exponent. We do not want x squared, we want x to the first. Okay, so the question becomes, how do you get the x off, or the squared off of the x so that x can be isolated? Well, just like any other thing, in order to move something from one side of the equal sign to the other, you have to do the opposite of what is being done. So the question is, what is the opposite of something being squared? And the answer to that is to take the square root. So we're going to take the square root of both sides of the equal sign, and then we're going to simplify from there. Now, many of you, probably through your travels in junior high, whenever you had to do a square root, that meant we grabbed a calculator, we pushed the funny little check mark button, and whatever number came out of the check mark button, then we just rounded it off and wrote it down, and that was good enough. Well, welcome to high school. That's not good enough anymore. We are going to simplify our radicals manually. And what that involves is simply two things. You are going to factor what is underneath your radicals. That means breaking it down into the most simplistic terms that it can be broken down into. For example, 25 is 5 times 5. X squared is x times x. Okay, so we factor our values underneath the radical, and what we're looking for underneath the radical is pairs of stuff. We want to find 2 of something underneath the radical. If we can find 2 of something underneath the radical, that pair of things will join together, and in the process of joining together, they get to come outside of the radical. So on the left side, we have a pair of 5s. So the pair of 5s underneath the radical gets to join together and come outside of the radical and make a 5 outside of the radical. Since there would be nothing left underneath the radical is gone. Similarly, on the right side, you've got x and x, got a pair of x's. They will join together. By joining together, they come outside of the radical and make a single x outside of the radical. And since there's nothing left underneath the radical, then their radical is gone. Okay, now that's probably a good bit of over-explanation for a value like 25. I think a lot of people knew that the square root of 25 was 5. That one's pretty easy. However, it's not always such a nice number underneath the radical, and simplifying can become a little bit more complicated. Okay. This particular type of a problem is called a Pythagorean triple. This is kind of fancy vocabulary, but you do need to know it. A Pythagorean triple occurs when all 3 sides of a right triangle are whole numbers. That does not happen very often, and many times what will happen is you may end up with 1 whole number or even 2 whole numbers for your side lengths, but the third one will be some kind of a radical that will not simplify. Let's move on and look at another one. In this case, we have another right triangle. That's good. That's the hypothesis of the Pythagorean theorem if your figure is a right triangle. Yes, it is. That allows us to use the Pythagorean theorem. We have 2 side lengths, 5 and 13. We have a missing side length, s. Now we're going to write down our Pythagorean theorem without anything plugged into it. A squared plus b squared equals c squared. And we must get the hypotenuse positioned correctly. The other 2 guys, A and B, they can be in either order that they want to be, but you got to get the hypotenuse right. Okay, so let's look into the picture. What is the hypotenuse? In this case, the hypotenuse is the 13, making the s and the 5 the legs. So plug in your values so that 5 and s get the A and the B, and 13 gets the C. Okay, now we just proceed to solve for the variable. This time it's an s. Okay, we have some values that we can simplify. Okay, you got 5 squared on the left, that is 25, and 13 squared on the right. You may not have that one memorized, but that one is 169. Okay. Now, obviously, you can see the s squareds sitting there on the left-hand side, so we'd probably better get the 25 away, move it over to the right. So we would subtract 25 from both sides. Now that'll leave the s squared on the left, and 169 take away 25 is 144. Okay. Now what we're going to need to do is to get the squared off of the s, and in order to do that, we do the opposite of something squared, which is taking the square root. And of course, whatever we do to one side, we must do to the other. Okay. Now we're going to factor underneath the radical. We're going to break these values down into their most simplistic terms. Okay, obviously on the left we're going to get s squared. That'll be s times s. Now 144 breaks down a lot of different ways. Okay, so some people will start off with maybe 72 times 2. Other people may start off with something like 36 times 4. Okay, there's a lot of different ways that it breaks down. The point will be, it does not matter how you break it down, as long as you break it down correctly, we will all get to the same answer. Okay, so let's begin. Okay, s squared will break down into s times s. 144 will break down into 12 times 12. And again, a lot of people will see it in different ways and start different places. That's fine. Okay. S and S will not break down any further, so that's as far as they can go. Okay. Those two S's that are underneath the radical are going to pair together. In doing that pairing, they will come out of the radical. There will be one s outside of the radical. There's nothing left underneath the radical, so the radical goes away. S will be the simplified version. On the right side, 12 and 12, those are not simplified yet. So we'll simplify them by breaking them down even further. Okay, 12 could be 4 times 3, or it could be 2 times 6. Okay, so we're going to continue to break it down. And we will continue to break these numbers down until they cannot break down any further. Okay, well, there's the S on the left side. We already knew that was going to happen. And on the right, the 3's are prime. That's as low as they can be broken. But the 4's can be broken down even further into 2 times 2. Now, if you're confused or concerned that you might make any silly mistakes when you are breaking these down, once you get all the way down to the prime numbers, like we have here, you can always type this back into your calculator to see if you made a mistake. So if you type 2 times 2 times 3 times 2 times 2 times 3 and press enter, you should get 144 back. If you don't, then you've made a mistake. Okay, but more importantly, we have reached all of the prime numbers. They will not break down any further. So let's look and see what pairs we might have found. Now, if you look at the look underneath the radical, I think you can see that you have a pair of 2's there on the left. You also have a pair of 2's over towards the right, and you also have a pair of 3's. The fact that the two 3's are not sitting side by side with each other really does not have anything to do with anything. The important part is there are 2 of them. Okay, so the first set of 2's are going to join together and they will come out. That will put a 2 outside of the radical. The two 3's will join together and they will come out. That'll put a 3 outside of the radical. And the second set of 2's will join together and they will come out, and that will put a second 2 outside of the radical. Now, the math that goes on as these values start piling up outside of the radical is multiplication. Okay, so the 2 and the 2 and the 3, those were the results of the 3 pairs that we found. They're going to multiply. 2 times 2 times 3 is 12. Okay, so the left side of the equation now simply says S. The right side of the equation now says 12. And that is our answer. Our missing side length was 12. So as you can see, the Pythagorean theorem has not changed, but some of the math that you're going to have to do, the way that you're going to have to work it out, may seem a little bit different. Let's look at one more together. Okay, again, it's a right triangle. Anytime you have a right triangle, Pythagorean theorem is at your disposal. Okay, so let's take these three side lengths. In this case, we have an m and a 4 and an 8. We have to make sure that we get the hypotenuse in the right place. Okay, so which side's going to be the hypotenuse? This time it will be the 8. Okay, simplifying our values, we have a 4 squared, which is 16, and we have an 8 squared, which is 64. Okay, getting the m squared isolated, that 16 does not need to be there, so we will subtract it to the other side. And then that leaves you with 64 minus 16. That would be 48. Now, in order to simplify the m squared, we would take the square root of both sides. And this time, we're going to run into a little bit more of a problem. Okay, this time, our triangle is not going to be a Pythagorean triple like the other two were. It's not going to simplify to be a nice, neat whole number. But let's break it down. Okay, hopefully you can see by now that the m squared on the left, square root of m squared is going to be m. Now the 48 is a little bit tougher. We're going to need to break it down. And again, different people are going to see it in different ways. Just pick any two good factors of 48 and write them down. I'm going to start with 6 and 8. Obviously on the left, you're going to get your two m's. They're going to pair together, come outside, and make an m. 6 on the right side is not simplified. It can be broken down into 2 times 3. 8 can be further broken down into 2 times 4. And the right side is not quite finished yet. The 2 is prime, the 3 is prime, the 4 is a composite number, meaning it is not prime yet. So it can be broken down further into 2 times 2. And then, of course, you have the final 2 sitting over there. Okay, once you have your values broken all the way down into prime numbers, nothing else can be broken down. Look for pairs of stuff. I see a pair of 2's. You got a 2 at the very left and a 2 in the middle. There's a pair of 2's. And then you have a second pair of 2's hanging on to the right side. Okay, so we're going to get one pair of 2's. That'll make a 2 outside. And then you have another pair of 2's. That'll make another 2 outside. However, that poor lonely 3 that was underneath the radical does not have anybody to pair with, so he is going to be stuck underneath the radical. The two 2's that came out are going to multiply together, just like we had on the last problem. That will give you 4 square roots of 3. Okay, this will not simplify any further. 3 is a prime number underneath there and did not have anybody to pair together with. This is our answer. Sorry about that, an alarm just went off on my phone. Okay, and our value is m equals 4 square root of 3. Now this is where things are different from they were in the junior high days. In the junior high days, you would just push the square root button on your calculator and get some decimal point saying 6.8 blah, 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 blah. Okay, problem is, when you get to your ACT and your SAT test, you are not going to have calculators to help you. So your answer will look like the answer that is on the screen now. And if all you know is how to push the button on your calculator, you are going to be in some trouble when it comes time to take those tests that really matter. Okay, I'm going to quit spending your time now. There's one more question. I want you to apply the Pythagorean theorem to this question. I want you to simplify the radicals manually and show your work. And we will cover this problem in class together when we get to class. And I want you to have this one done so we can see if your answer and my answer are going to be the same answer. I appreciate you finding time to do your notes, and I will see you in class.